In the 12th century, European builders were driven by a single theological mandate to physically manifest heaven on earth. This meant designing spaces around the concept of lux nova, the belief that radiant light was the literal presence of the divine, and a vertical aspiration that drew the soul upward. But this ethereal ambition faced a brutal physical constraint. Buildings were made of stone, and stone is relentlessly heavy. For centuries, the Romanesque style had managed this weight through mass, defining the landscape of Western Europe from the 9th to the 11th centuries. Romanesque engineering prioritized stability. These structures utilized thick walls, solid piers, and heavy barrel vaults to withstand the immense pressure of the masonry. Because a heavy stone roof required massive walls for support, architects were forced to keep windows small. These interiors felt safe and solid, but they remained dark. The Gothic style emerged near Paris as a radical rebellion against these physical limits, seeking to replace mass with light. This required a transition from continuous load-bearing walls to an articulated load-bearing skeleton. To turn stone walls into sheets of glass, engineers had to redirect the load of the roof through an external structural exoskeleton. Despite their visual differences, both styles utilized the exact same geometric footprint and materials. This is the Latin cross plan, the standard layout of the medieval cathedral, designed to reflect the shape of Christ's crucifixion. The structure is defined by three main zones: the long nave for the congregation, the perpendicular transepts, and the choir. Romanesque builders used this plan to build low, heavy structures. Gothic architects used the same footprint to reach heights of 33 meters, and they did it by solving a problem of physics. That problem is lateral thrust. A curved stone roof converts the vertical weight of gravity into a diagonal force. The arching stone presses outward against the sidewalls, threatening to push them apart. Romanesque builders absorbed this force by building incredibly thick walls, which left little room for windows. Overcoming this required the Gothic triad, three innovations that managed lateral thrust without relying on the weight of the wall. Achieving verticality and light meant abandoning the solid wall entirely, beginning with the geometry of the arch itself. The first component of the Gothic machine is the pointed arch. This diagram compares the geometry of the pointed arch to the traditional Roman semicircle. A round arch generates massive lateral thrust, driving weight horizontally into the supporting structure. The pointed arch concentrates weight on a steeper, downward trajectory, which minimizes the outward push. This allows for wider spans and greater heights without requiring thicker columns. This geometric solution was not an original European invention. It was a technology encountered in the Islamic world. Builders systematically used pointed arches in 8th century Islamic architecture, including the Al-Aqsa Mosque and the Palace of Uqaydar in Iraq. This engineering knowledge reached the West through the Crusades and interactions in Al-Andalus, where scholars translated Arabic texts on geometry and engineering. While Islamic builders used this form to express geometric harmony, European architects used the same physics to reach toward the heavens. The second component is the ribbed vault, which applies the physics of the pointed arch in 3 dimensions. Intersecting pointed arches create a skeletal grid of stone ribs. These ribs carry the entire load of the ceiling down to specific points. Because the ribs handle the load, the webbing between them can be made of thin, lightweight stone. As vaults reached the 33-meter height of Notre Dame, the outward push from the roof's mass and high-altitude winds became too great for the interior columns to handle alone. To prevent the cathedral from collapsing outward, builders in the 1170s deployed the final innovation, the flying buttress. This cross-section shows the flying buttress acting as an external prop that catches the lateral thrust mid-air. The weight of the interior vault travels down the curve of the buttress, over the side aisles, and grounds into heavy stone piers on the outside. This network effectively turns the building inside out, moving the structural supports to the exterior. By moving the weight to external piers, the interior walls were suddenly freed from their structural duties. This led to the architectural dematerialization of the wall. With the ribbed vaults and flying buttresses handling the weight, the stone walls between the columns were no longer necessary for stability. Architects replaced that stone with curtain walls of stained glass. The rose window is the ultimate expression of this shift. Its stone tracery acts as a structural web, distributing loads while supporting massive expanses of glass. These windows achieved the goal of lux nova, transforming the cathedral into a space defined by light. The exterior walls served as public education. Sculpted portals, like this depiction of the Last Judgment, preached visual sermons to medieval worshippers. In just a few generations, architecture moved from the solid fortresses of the Romanesque era to skeletal, gravity-defying Gothic cathedrals. The construction of these defining Christian monuments relied on geometric engineering translated from Arabic texts. The symbol of European aspiration, a cathedral made seemingly of pure light, was engineered upon the bedrock of Islamic geometry.